Now next property of acids, reaction of acids with the metal hydroxides. Remember this, metal hydroxides are generally bases. Okay, so we can also take this reaction of acids with the bases. What happens? Do you remember we have already learnt how acids and bases react with different indicators? Yes, if I take phenolphthalein indicator, what happens? How does phenolphthalein reacts towards acids and bases? With acids, phenolphthalein is colorless, whereas with bases, phenolphthalein turns to pink color. Right? Let us use this indication test to understand reaction between acids and bases. Okay. So for that, what I am going to do is, I take a beaker. To this beaker, I take a few ml of a dilute base, dilute sodium hydroxide. I told you metal hydroxides are bases. Since sodium is metal, its hydroxide is NaOH, which is a base. Take some dilute sodium hydroxide, and to this I add a few drops of phenolphthalein. Few drops of phenolphthalein is added to this. Then what happens? This dilute solution turns to pink. So I'll write here NaOH solution plus phenolphthalein is added. Then the solution turns to pink color. We know phenolphthalein turns basic solutions to pink color. Right? Now, what I do, I add few drops of dilute hydrochloric acid. And then I stir the solution. Then what I do to this pink solution, now I add few drops of dilute hydrochloric acid and I stir with a glass rod. Then what happens? What do you think it happens? This pink color, the pink solution disappears when I add a few drops of hydrochloric acid, and when stir it becomes colorless. Why it becomes colorless? Because whatever pink color is obtained because of basic nature of sodium hydroxide is removed. It is cancelled. The basic nature of NaOH is cancelled when acid is added to this pink color solution. Now what I do, I take this colorless solution and I add a few drops of dilute NaOH, and then I stir it again. I add few drops of NaOH again. First I took NaOH, then I added phenolphthalein, it became pink color. Then to this pink solution, added acid and stir well, so it became colorless. Pink color disappeared because basic properties of NaOH are cancelled, right? Then I take this colorless solution, add few drops of NaOH and stir. Then again the pink color is reappeared. Why do you think pink color reappeared? Because it acquired basic property, or whatever a colorless solution is because of addition of acid. Now it has some acidic properties, we all know. Phenolphthalein becomes colorless with the acids. So when I added acid, it becomes colorless, become acidic solution. And when I add dilute NaOH, the acidic solution, the colorless solution characters are cancelled and restored the pink color, basic properties. Is it clear? So whenever I added, we can repeat this again. I take again the pink solution, add few drops of dilute HCl, and I stir well with glass rod. Then again it turns to colorless. You can repeat this experiment n number of times. So every case, in every time, what happens is basic properties are neutralized by acid properties are neutralized by base. Okay, the properties cancel each other, acid and base, their properties cancel each other, and as a result acid becomes, whenever acid is added to base, it happens neutralization of the acidic characters, neutralization of the basic characters. The characters are neutralized with each other, cancelled each other. So the reaction of acid to base is called neutralization reaction. And as a result of neutralization reaction, the products are always produced salt and water. Okay, this reaction is called neutralization. Right? Now, let us take example. What examples I've taken? Acid is HCl, base is NaOH. I take dilute acid HCl and a base NaOH. Then, what is a salt? Water is one of the products. It is okay, water, constant formula. But salt, when you take different acids and bases, the salt nature also changes. Different salts we obtain. And here, to write the formula of salt, see, generally salt is ionic compound that is formed from cation of base and anion from acid. Cation is a metal atom, forms cation from base, and non-metal or a negative ion of acid. Okay, these two combine with each other and forming a salt called NaCl. In this case, sodium is monovalent, chlorine also monovalent. So the formula of sodium chloride is NaCl plus water H2O, and this is a balanced chemical equation, 2 hydrogens, oxygen and H2O. Right? If I take other acids, if I take H2SO4 reacts with a base called NH4OH. This is called ammonium hydroxide. Ammonium hydroxide, we generally imagine NH4 plus 1 OH minus 1. When this ammonium hydroxide is added to water, it produces ammonium ion and hydroxide ion. Now, this is, for your understanding, I'm writing here. Okay, this is plus 1, this is minus 1. Okay, sulfate ion minus 2, hydrogen is plus 1 generally. Right? Now, what happens is, whenever this dilute acid is added to ammonium hydroxide, this positive ion from base combines with negative ion of acid, NH4 plus 1, SO4 minus 2. You know crisscross method. As a result of crisscross method, we get ammonium sulfate. It's called NH4 taken twice SO4. Ammonium sulfate and other product is water. We have to balance it. 2 ammonium groups, I write 2 NH4OH and sulfate. This is how balanced chemical equation for the reaction between sulfuric acid and ammonium hydroxide. It is a acid, this is a base. So this reaction also it represents a neutralization reaction. Okay. Yeah, the next property of acids, reaction of acids with metal oxides. What are metal oxides? We know any metal reacts with oxygen, form its metal oxide. It is right from highly reactive potassium to least reactive copper. Right? All these metals generally reacts with oxygen, form their metal oxides. For example, potassium combines with oxygen, form potassium oxide. Sodium forms sodium oxide. Like every metal form its own oxides. Now, how those metal oxides react with the acids? Right? Now, the reaction we see generally like this. Acid solution reacts with the metal oxide. It always produces salt and water. Salt and water. So you see, salt and water are the products of earlier chemical reaction. What is it? Neutralization reaction. In neutralization also, products are salt and water. When acid react with metal oxide, also products are same, salt and water. And now let us take acids. If I take a dilute hydrochloric acid and it reacts with a metal oxide. What metal oxide? Let me take here magnesium oxide. Magnesium oxide formula is MgO because both are bivalent ions. They form bivalent ions, Mg plus 2, O minus 2. Formula is magnesium oxide. When it reacts, it produces salt. What is a salt? Salt is always formed metal from metal oxide and negative ion from the acid. So this Mg and chlorine, magnesium plus 2, chloride is generally forms chloride ion, Cl minus 1. So it forms a magnesium chloride salt. It's MgCl2 plus what is another product is water. After writing the products, we should not forget to balance the chemical equation. 2 chlorines, 2 hydrogens, I simply make it 2. That's all it balanced. Next, let me take other metal oxide like aluminium oxide. Let me take Al2O3. It produces salt AlCl3 plus water. How do we balance it? We have 3 chlorines. So let me take two aluminiums, right? Let me make two aluminiums. 2 3s are 6. So I'll write 6 hydrogens. I'll write 3 2s are 6 hydrogens. 3 oxygens, 3 oxygens. This is balanced. So acid reacts with metal oxides like magnesium oxide or aluminium oxide. The products are salt and water. Let us see HCl when reacts with the metal oxide, zinc oxide, it produces salt, zinc chloride and water. So we balance it. If I write 2, it is balanced, right? Then if I take another acid, H2SO4 sulfuric acid, how does it react with the various metal oxides? So let me take for example potassium oxide, K2O, right? K plus 1, O minus 2. Then it produces salt, potassium and sulfate. We get K2SO4, potassium sulfate plus water is produced. Then if this H2SO4 reacts with the magnesium oxide MgO, it produces a salt, magnesium sulfate plus water. Okay. Now, all these cases, the products obtained are salt and water. So we can write a general equation when acid reacts with metal oxide, it produces salt and water. Okay. And now in this chemical equation, you see, let us compare this one with the neutralization reaction. In neutralization, what happened, Nana? Acid reacts with the base to produce salt and water. And now let us write this general equation. When acid reacts with the metal oxide, it produces salt and water. Right? Products are same. One of the reactants is acid is same. This is same. Okay. This salt is same. Water is same. Okay. What is the different one is? In neutralization we use base, but in this reaction we use a metal oxide. The actual thing is the second reaction is also called neutralization reaction. These two are neutralization reactions. Okay. In this reaction, why are these two called neutralization reactions? Because the chemical reaction in which salt and water are the only products, then the chemical reaction is called neutralization reaction. So whenever acid reacts with base or acid reacts with metal oxide, the products are only salt and water. So these two reactions are called neutralization reactions. But what's the difference? In this case, the metal oxide that is taken is acting like a base. Metal oxide is acting like a base. So we conclude an important conclusion, that is metal oxides are behaving like bases. So metal oxides are generally considered to be a basic oxides. Basic oxides, they are also called basic anhydrides because they are reacting with acids the way bases react with the acids. So since they resembles bases in chemical properties, metal oxides are basic oxides or basic anhydrides. In all these examples, you see magnesium oxide, aluminium oxide, zinc oxide, potassium oxide. All these metal oxides, not just only these metal oxides, but also all other metal oxides are also considered basic oxides or basic anhydrides. Okay. Please note down all the reactions and do practice to get more perfection in writing chemical equation and also balancing equation. Right? I hope every equation is balanced.